Good evening, students. So now we are going to study about polarization. So what is polarization? This is what I am going to explain you. And what is the effect of polarization in the dielectric materials? So dielectric materials already we have studied. The insulators in short are known as dielectric. Okay. And dielectrics are of two types. One is polar, another one is non-polar. Polar is a kind of material which are having a permanent dipole moment, and that permanent dipole moment is because of the symmetrical shape. And the kind of material which are non-polar means they are not having any dipole moment in the absence of external electric field. So what is the meaning of polarization? So when such kind of insulators or such kind of dielectrics, when they gain the permanent dipole moment when external field is applied to them, that is known as polarization. So polarization is a name which can be given to a substance or to a molecule when it is getting the dipole moment. So the process when we apply the external field, and because of the external field, okay, because of the external field, the dielectric material align themselves in the direction of dipole moment, or they get the dipole moment, that is known as, that process is known as polarization. So we are going to study polarization for two kind of materials, one non-polar, another polar. Non-polar are which kind of dielectrics? We have studied that non-polar dielectrics are not having any kind of dipole moment. And why it was holding out? It was holding out because the center of positive charge and the center of negative charge were coinciding or at the same point. So students, for such kind of non-polar, so I will make two conditions. Firstly, I will take the external field as 0, okay, and here I will apply some external field, and I will find when the external field is applied what is the influence of it, and in the absence of external field which kind of behavior they are showing. So in the absence of external field, these are which kind of non-polar. So for non-polar there is no dipole moment, so the center of positive charge and the center of negative charge should be at a same point. Both should be coincide for each kind of molecule. So students, we can clearly see that the dipole moment of such kind of material is 0. Why it is 0? Because there is no distance between the center of positive and the center of negative charges. So 2L is 0, so the dipole moment is 0. Okay, in the absence of external field, this we can see clearly. Now students, what will happen when we will apply the external field? So students, when we will apply the external field, think about this, okay. Suppose I have a kind of material, dielectric material, which is a non-polar, okay. So this non-polar dielectric material I have placed somewhere where electric field has been applied. So when you will apply the electric field, okay, because of this electric field, what is the meaning of electric field? So students, meaning of electric field is there is a very large positive charge and there is a very large negative charge. So from the higher potential to the lower potential, the electric field is applied. What will held out? Basically, what is going to held out? This is going to held out that positive charge of this dielectric, which was aligned on the center, will attract towards the negative, okay, will attract towards the low potential, and the positive charge will the negative charge will align at the high potential. So positive charge is going to align on the negative potential and negative charge on the positive side. Why this is holding out? This is very simple. We already know one thing, that one positive charge always align itself in the direction of applied field. So this is the direction of applied field. So this positive charge will align itself like this positive charge, and this negative charge will align itself like this. So earlier, when no external field was present, the condition for the non-polar dielectric was like this, okay, means these were aligned at the center and both were coinciding. But when we applied the external field, both are aligned and both are separated with a little separation, okay, and this is holding out. And same for this material. So positive will go in the direction of field and negative will go in the opposite direction of field. Similarly for this, okay, and similarly for all non-polar dielectrics. So now students, earlier the dipole moment was 0. So now will the dipole moment be 0? So our answer is no. The dipole moment will not be 0, as we can clearly see that there is a separation between the center of positive charge and the center of negative charge. So we can say that because of the electric field, they have aligned a permanent dipole moment. So we can say that non-polar dielectrics gets the dipole moment when electric field is applied. And what will be the direction of that dipole moment? The answer is from the negative to the positive. Okay, so this is going to be the direction of dipole moment. So this is very clear that polarization affects the non-polar dielectric material and they get the permanent dipole moment when external field is applied. So students, now we will see the effect of polarization on a polar dielectric material. What are polar dielectric material? The answer is they are asymmetrical in shape, so they are having a permanent dipole moment in the absence of electric field. Okay, so which kind of dipole moment they shows? So we are going to observe it. So students, this is how they show the dipole moment: negative, positive, they are having the random direction. Okay, the molecules are aligned for, and this is what the condition is when no external field is present. So I have shown the condition when no external field is present. So students, they are randomly distributed. Okay, and why they are randomly distributed or why they are showing the dipole moment? The answer is they are showing the dipole moment because of the thermal energy. Okay, if even we don't apply the electric field, then even one kind of energy is present, and that is thermal energy. And because of the thermal energy, they are randomly oriented somewhere, and this particular is having a dipole moment is in this direction, this is having in this direction. So each molecule are aligned opposite to the second one, and because of this the net dipole moment is 0. One particular molecule may have a dipole moment, but the total dipole moment, they are aligned in a particular direction such a way that the total dipole moment is going to be 0. So net dipole moment is 0, but individual molecule have some dipole moment. Now what will be there when we will apply the external field? So when you will apply the external field, E naught is not equal to 0 now. So what is the condition going to held out? They will align a permanent dipole moment. Just in the similar way, this is how they will be oriented. So they will show the dipole moment in a particular direction, and they will behave very similar to that of the non-polar dielectric material. So we can say that either we are having the non-polar dielectric material or we are having the polar dielectric material. When external field will be applied, then they will acquire a permanent dipole moment, and because they will acquire the permanent dipole moment, so this process is known as polarization. Now students, one thing which you have to take care about, that this dipole moment of that polar dielectric material depends on two factors. So these two factors are the potential energy of the dipole in the external field. Okay, so this is depending on the potential energy of that particular dipole, that how much energy has been acquired. One more thing, thermal energy. Okay, because once you apply the field, because of the field, these are getting the permanent dipole moment, but there is a thermal energy which wants to rotate these particular dipoles in random direction. So how much dipole moment they will acquire, this depends on the thermal energy as well. So this you have to remember. And one more thing which you have to remember is polarization. I have told you, okay, because the molecules, the dielectric materials acquire the dipole moment, and this process is known as polarization. One more thing which you have to remember is polarization density. What is polarization density? So the answer for polarization density is the dipole moment dipole moment per unit volume is known as polarization density. Okay, the dipole moment per unit volume is known as polarization density, and this is denoted by capital P, and this is a vector physical quantity. So please remember this whole topic. I hope that you understood this. Thank you. God bless you.